everyone, I am Vijay Krishna. Today we are dealing about lubrication regimes in the subject engineering tribology. Okay, lubrication regimes. Now you can see the various types of the lubrication regimes. In that you will be having hydrodynamic and the hydrostatic, and you also having the theory of lubrication, and the lubrication systems also will be there. Now see here, before going for the lubrication regimes, we will try to see what is the lubrication. The object of the lubrication is to reduce the friction, wear, and the heat generated during the relative motion of the parts. Lubricant is nothing but a substance that, when we inserted between the two surfaces, accomplishes these purposes. Okay, the examples of the lubricating systems are sleeve bearing, shaft, and general, all will oscillates within the sleeve. Next point, in an anti-friction bearing, the main relative motion is rolling. Example, cam and follower also will be examples of the lubricating systems. Now we will try to see what is lubrication regimes. In lubrication regimes, you will be having the two criteria: main hydrodynamic lubrication and the hydrostatic lubrication system. In hydrodynamic lubrication system, the oil film is formed by the relative motion of the friction surface, whereas in the hydrostatic lubrication, the oil film is formed by the external pressure of the oil. In general, in a hydrostatic lubrication system, instead of the grease and instead of the semi-liquid lubricants such as grease, we will be using the oil, which will be pressurizing from the external sources. Okay, in hydrostatic one, due to oil film is formed due to the externally pressured oil will be there. Okay, next we will try to see what is hydrodynamic lubrication in detail. In hydrodynamic lubrication, the load carrying the surfaces of bearings are separated by the thick film. Load carrying surfaces are separated by the thick film of the lubricant, so as to prevent the metal to metal contact, and thus the stability can be explained by the laws of fluid dynamics. Hydrodynamic lubrication is also called as a full film lubrication and the fluid lubrication. In hydrodynamic lubrication, there is a more gap between two metal surfaces. Because of that reason, more lubricant is filled between them. Okay, and that we will call as a thick film lubrication, so as to prevent the metal to metal contact in between them. Hydrodynamic lubrication is also called fluid lubrication or full film lubrication, because more space is available between the two metal surfaces, that more space is filled by the lubricants. So because of that reason, it is called as a full film lubrication or the fluid lubrication. Now we will try to see what is hydrostatic lubrication. Hydrostatic lubrication is obtained by introducing the lubricant. Okay, the lubricant may be air, water, okay, that is pressurized between the two surfaces. Unlike the hydrodynamic lubrication, the kind of lubrication does not require the motion of relative motion. In hydrodynamic lubrication, what we will call relative motion is required between the two surfaces, whereas in hydrostatic lubrication, relative motion is not required between the surfaces. Okay. Now we will see what are the lubrication regimes. Lubrication regimes are nothing but sliding friction will occur due to the addition of the lubricant and the rubbing surface between them. Okay. Generally, lubricating regimes are classified based upon the ratio of what we will call surface characteristic number, surface roughness number RA, and the what we will call oil film thickness HA. Okay, these two terms plays a major role, H and RA. H is nothing but the fluid film thickness and RA is nothing but the surface thickness. Okay, if H is less than RA, it will consider as a one type of lubrication. If H is equal to Ra, then it is considered as a one type of lubrication. And if S is greater than Ra, then it is considered as another type of lubrication. Okay, based upon the relation between the oil film thickness and the surface roughness thickness, lubrication regimes are classified. Now we will see what are the different types of lubricating systems and how they are play the major role in the lubricating system. We will try to see. Okay, now we will see what we'll call. First one, we will try to see the boundary lubrication system. As we discussed in the previous slide, lubrication regimes depends upon what we will call H, relation between H and Ra. If oil thickness film H is less than Ra, surface roughness, then we will call as a boundary lubrication. Okay, in boundary lubrication regime, the constant contact between the friction surface at the high surface points occurs at the boundary lubrication. Nothing but constant contacts. Nothing but what we will call in the boundary lubrication system, there will be contact between the two surfaces for maximum amount of time. Okay, this regime is mostly undesirable. Why this regime is undesirable? Because here high, because of the constant contact between the surface, high coefficient of friction will occur. Okay, when the more friction is occurring, there is a chance of increased wear here, and the possibility of seizure will occur between the bearing and the general materials. Okay, in addition to that, you will be having the non-uniform distribution of the bearing load and the at the pressurized peaks. Okay, boundary lubrication is nothing but what we'll call there will be contact between the surfaces will occur for more number of time, more amount of time. Because of that one, friction rate will be more, and because when the friction is more, wear will occur, wear also increases over there. Due to the boundary lubrication, there is a chance of possibility of seizure of the metal surfaces. Seizure is nothing but the locking of the surface tips between the surfaces. And in addition to that, there will be non-uniform distribution of bearing load will take in the boundary lubrication. Okay, due to the boundary lubrication, there are chances of severe engine bearing failures will occurs in the boundary lubrication. Okay, the condition for the boundary lubrication realized mainly at the low speed friction and the high loads. Boundary lubrication will take place at a low speed lubrication and the high speed loads. Okay, if you want to, the remedy for the boundary lubrication is nothing but addition of extreme pressure additives in the lubrication. If we able to add the additives into the lubricate, we can prevent the seizure condition. We can prevent the seizure conditions caused by the direct metal to metal contact between the parts in the boundary lubrication. Okay, due to the boundary lubrication system, there is a chance of metal to metal contact. As a result of, there is a chance of seizure or seizing of the metal surface. That can be avoided with the help of adding additives to the lubricant. Now we will see about the mixed lubrication. In the previous slide, we have seen about the boundary lubrication where H is less than Ra. Okay, in mixed lubrication, H is approximately equal to what we'll call Ra, where H is nothing but the surface thickness and H is nothing but the oil film thickness and Ra is nothing but surface film thickness. Okay, if H is approximately equal to Ra, then we will call as a mixed lubrication. Okay, mixed lubrication, the name itself indicates that it is an interment region between the boundary lubrication and the hydrodynamic lubrication. Here, in the mixed lubrication, you will be having the intimate contact between the surfaces at a few high surface points occurs at the mixed lubrication. Okay. Now we will try to see the hydrodynamic lubrication regime. Here, H is greater than Ra. Okay. Oil film thickness is greater than what we'll call the surface roughness. In hydrodynamic lubrication, high rotation speed. In hydrodynamic lubrication, high rotation speed at relatively low bearing load results in the hydrodynamic lubrication. When high rotational speed is occurring and the low bearing loads are taking place, in such cases we will call as a hydrodynamic lubrication. In simple, hydrodynamic lubrication will occur at low bearing loads and the high rotation speeds, which are characterized by stabilized oil film between the rubbing surfaces. Okay. And now next point we will try to see. No contact with the surface occurs in the hydrodynamic lubrication. Because in the hydrodynamic lubrication, there is a more space between the two surfaces, as a result of which more lubricant is present in between them. Because of that reason, no contact with the surfaces occurs in the hydrodynamic lubrication. Next point. The squeeze film keeps the surface of the bearing and the shaft apart due to the force called hydrodynamic lift. The squeeze film keeps the surfaces of the bearing and the shaft due to the force called hydrodynamic lift generated by the lubricating squeeze through the convergent gap between the eccentric journal and the bearing. Okay. Whatever the fluid is acting in between the hydrodynamic lubrication, which occurs in the hydrodynamic general bearing, is separated by the fluid. Okay, that fluid will plays as a major role keeping the surfaces in contact. In that one, hydrodynamic lift will take place. Hydrodynamic lift is nothing but the lift force which will enhance the surfaces between the hydrodynamic lubricant. Bearing working under the conditions of hydrodynamic lubrication are called as a hydrodynamic general bearing. The bearings which are working under the condition of hydrodynamic lubrication is known as a hydrodynamic general bearings. Now you can see the diagrammatic representations of the various lubricating regimes. Here the graph is plotted between what we will call coefficient of friction on the y-axis and the bearing parameter on the x-axis. Okay. Now you can see in the boundary lubrication, the bearing curve, this curve is lubrication Stiebeck curve is what we'll call straight. It is the straight, and whatever in the mixed lubrication there is a drastic drop is there in between the what we'll call, because this is a phase between the boundary lubrication and the hydrodynamic lubrication. In boundary lubrication, you will be having the Stiebeck curve, linear variation will be there, but in the mixed lubrication in the regime, there will be drastically reduced in that one. Whereas in hydrodynamic lubrication, it's going on increasing regularly with the bearing parameter. You can also see the representation in the downside. Here you can see here. Here you will be having the less space between the contact surfaces, boundary lubrication. So here you will be having the more space. You can see at some point of contacts it will be there, contact will be there. Okay. Whereas in the mixed lubrication there will be no contact points will be there. Somewhere you will be having the more space and somewhere some points you will be having the less space. Okay. Because of this reason, you will be having the mixed lubrication system. Here, when the more space is there, it is going on decreasing. At the contact point, it will be having the less point. Okay, you can see the hydrodynamic lubrication system. Here, Because of the more fluid in between the surfaces, contact metal to metal contact points are very less. Okay. Now you can see the same explanation of that one. The three lubrication regimes are clearly distinguished in the Streeback curve, okay, which I have seen in the previous figure. We demonstrate the relation between the coefficient of friction and the bearing parameter, okay, where bearing parameter n into efficiency n into mu into n by rho AV, where n is dynamic viscosity of the lubricant and n is the rotation speed and rho A is average bearing pressure. The stability of different lubrication regimes may be explained by means of Streebeck curve. Okay, the stability of the different lubrication regimes are explained by Streebeck curve. Okay, now we will try to see what it is. Streebeck curve. Temperature increases due to the heat generated by the friction, causes a drop of lubrication viscosity and the bearing parameter. When the temperature is increasing, generally when the two surfaces move in contact with each other, heat is generated due to the friction. When heat is generated, there is a chance of temperature increase. Okay, when the temperature is increasing, viscosity will be decreasing, as a result of which bearing parameter also decreases. Okay, next point. According to the Streebeck curve, the decrease of bearing parameter in the mixed regime causes increase of coefficient of friction. Further temperature rise will take place, as a result of which coefficient of friction also increases. Thus, mixed lubrication is unstable. Okay, now we will try to see the increase in bearing parameter due to the temperature rise in the hydrodynamic regime of lubrication causes the coefficient of friction to drop with consequent decrease of the temperature. The system corrects itself. Thus, the hydrodynamic lubrication is stable. Now we will try to see what will happen in the mixed lubrication system. In entering contact between the friction surface at high surface points occurs at the mixed lubrication. In mixed lubrication, there is the intermediate contact will occur. Nothing but intermediate contact is nothing but sometimes it will have the contact and sometimes will be having the less contact. Okay, nothing but the oil film thickness will be sometimes more and sometimes at some points it will be lesser. Mixed lubrication is nothing but intermediate between the boundary lubrication and the hydrodynamic lubrication. Okay. Now see hydrodynamic lubrication. A theoretical analysis of hydrodynamic lubrication was carried out by Osborne Reynolds. Generally, we will call as the Reynolds equation. Generally, most of the times, hydrodynamic lubrication analysis is done by the Reynolds equation. This equation resulted from analysis as served the basis for designing the hydrodynamic lubricated bearing. Generally, the what we will call basis for the hydrodynamic lubricated bearing is nothing but the Reynolds equation. Okay, what are the assumptions made in the Reynolds equations are the lubricating fluid is Newtonian fluid. Okay, the flow is laminar and the shear stress between the flow layers is proportional to the velocity gradient in the direction perpendicular to the flow. Okay, nothing but Newton's law of viscosity we will call shear stress tau is equal to efficiency mu and eta equal to dou v by dou y, that we will call as the Reynolds equation, and n is equal to dynamic viscosity, mu is equal to linear velocity of the laminar layer, and y is the axis perpendicular to the flow of direction. In general, in the hydrodynamic lubrication, all movement of the lubrications is followed by the Newton's law of viscosity, that is nothing but the Reynolds equation. Hydrodynamic lubrication system is also called as what we'll call fluid film, thick film, and flooded lubrication. Why these all terms are utilized? Because in hydrodynamic lubrication, there will be sufficient space between two surfaces which are in contact will be there. That sufficient space is filled by the lubricant. Okay, that lubricant because of the more application of the lubricant between the surfaces, we will be calling as a fluid film bearing or thick film bearing or flooded lubrication bearing. A thick film of lubricant is interposed between the surface of body in the relative motion. Because of that reason, it is called as a fluid film. There has to be pressure buildup in the film due to the relative motion of the surfaces. You will be having the more thick film lubricant between the surfaces in hydrodynamic lubrication. Because of that reason, pressure will be built up in between the surfaces. Okay, fluid friction is the substituted for the sliding friction. Okay, fluid friction is nothing but substitution for sliding friction. Hydrodynamic lubrication system. Hydrodynamic lubrication system is also called as a fluid film, thick film, or flooded lubrication system. A thick film of lubricant is interposed between the surface of bodies in the relative motion. There is a pressure buildup in the film due to the relative motion of the surfaces, and the fluid friction is substituted for sliding friction, and the coefficient of friction is decreased, and the prevalent in the journal and thrust bearing. In hydrodynamic lubrication system, we also called as a fluid film lubrication and thick film lubrication and flooded lubrication. A thick film of lubricant is interposed between the two surfaces, due to which a pressure is built up in film due to the relative motion of the surfaces. Fluid friction is a substitute for sliding friction. The coefficient of friction is decreased, and the in general and thrust bearings. Now you can see the parallel surfaces here, a lubrication, how lubricant is present in between the two surfaces. You can see the two plates over here, plate 1 and the plate 2. Here velocity profile, and this is the distance 1. And this is the entire region is we will call as the yellow part as a lubricant over here, and the velocity of the bottom of the plate is 0, and A is the area of the plate. Whatever at the top of this one, you will be having the velocity of plate equal to mu. Shear force F is equal to this one. The direction of the motion of the top plate will be in this direction. There is a no pressure buildup in the fluid due to the relative motion. When the two surfaces are relatively moving to each other, then there will be no pressure buildup will be take place. Pressure will remain constant throughout, influenced only by the load. Okay, the pressure will be constant as long as the load is there. When as the load increases, the surfaces are pushed towards each other until they are like to touch each other. When load goes on increasing, the surfaces are pushing towards each other until they are likely to touch each other. Now in hydrodynamic lubrication regime, you can see the diagrammatic representation here. This is bottom surface is flat and the top surface is somewhat kept with an angle of inclination. When angle of inclination take place, you will be having the force, normal force will be divided into the three component, lift force and the drag force. Okay, and the direction of movement of which will be like this. Okay, surfaces are inclined to each other, thereby compressing the fluid as it flows. When the surfaces are inclined to each other, compressing of the fluid will take place. This leads to the pressure buildup that tends to the force surface apart. Larger loads can be carried when the surfaces are inclined against each other. Now you can see the hydrodynamic theory of the journal bearing. Here, bottom surface is flat, similar to that one, previous one, and the top surface is inclined, and you can see the oil wedge over here. There. This one we will call as a bearing, and this we will call as a journal or the shaft. In between that is you will be having the lubricant in between. That's it. Oil wedge film between the journal and the bearing due to them not being concentric. Now you can see the velocity pressure distribution over here. Now you see this one what we'll call the bottom surface, and this one we'll call the top surface. In between the two surfaces you will be having the fluid will be there. Okay, this one we'll call as a diverging edge, and this we will call as a converging edge. Okay, now you can see at the edges pressure distribution is minimum, whereas in the middle pressure distribution is the maximum. Okay, you can see the here V1 is nothing but the velocity profile at the inlet, and V2 is the velocity profile at where maximum pressure is there, and V3 is the velocity profile at the outlet. Okay, here you can see the converging edge, here you can see the velocity at the diverging edge. Volume rate of the flow is same throughout the path. Therefore, as the height of the fluid decreases, velocity has to increase. When the height of the fluid is decreasing, the velocity will be increases, but volume flow rate will be the same throughout the passage. Now you can see the different types of the journal bearing, and with the eccentricity also consider. You can see the shaft and the journal. Okay, shaft or journal or bearing. You can, whatever this part we will call as the bearing, and this one is the shaft, and the yellow color is nothing but the fluid which is present in between them. Instead of starting, nothing but tends to climb up the bearing. Okay, at this point, and here while running. Slips due to the loss of traction and the concentric. Because of the eccentricity, the wedge is maintained. Okay, if the concentric shafts and bearings are there, wedge will not be maintained, and the fluid will be in the hydrodynamic lubrication. Nothing but the more fluid will be present here. Because of the eccentricity, wedge is the maintained over here. You can see here pressure distribution in the journal bearing, same way, same thing. Here you can see this is the bearing part, and this is the shaft or journal we will call, and this is the oil lubricating system. You can see the pressure will be profile is like this. Maximum pressure is reached somewhere in between the inlet and the outlet. You can see the maximum pressure is reached in between the inlet and the outlet at this top surface. You can see also this one tilting pad of the thrusting bearings. Okay, number of tilting pad forming will be the edges. You can see 1, 2, 3, 4. Okay, rotating this with pivoting pads, this one, and this is a fixed disc, and the wedge formation will take place in the gap between the two surfaces. Now here the movement will be in the axial direction. Here pressure distribution or the wedge formation also depends upon the number of the tilting pads between the forming wedges. Now you can see the tilting pad thrust bearing. Here you can see the bearing plate. Okay, and this is edge plate, and this is a tilting plate, and this is pivot, and this is a collar over here, and the direction of rotation you can see in this way. Here axial loads from machinery being driven, in the case the thrust from the propeller. The back thrust from water to propeller causes the axial load on the shaft. The back thrust, whatever thrust is acting from water to propeller, causes the axial load on the shaft. And axial loads are opposed by the pressure buildup in the wedge and gives the damping effect. Okay, whatever the axial load is occurred due to the back thrust of the water will give the damping effect. Damping effect is nothing but slightly reducing the influence of the pressure. Now you can see the hydrodynamic lubrication characteristics. The fluid film at the point of minimum thickness decreases in decrease in thickness as load increases. Okay, now you see, if the thickness is decreases, load is increases. When load is increasing, the thickness will be decreasing, will take place. The pressure within the fluid mass increases as the fluid film thicknesses decreases due to the load. Pressure will be increasing when the what we will call film thicknesses decreases. Film thickness decreases due to the increase of the load. Now you can see pressure within the fluid mass is great at some point approaching the minimum clearance and lowest at the point of maximum clearance. Pressure will be maximum at the what we will call minimum clearance, and the pressure will be minimum at the maximum clearance. Film thickness at the point of minimum clearance increases with the use of more viscous fluid. With the same load, pressure increases as the viscosity of fluid increases with given load and the fluid. The thickness of the film will increase as the speed is increased. The fluid film increases as the viscosity of the lubrication becomes greater. Now you can see the hydrodynamic condition fluid velocity. Fluid velocity depends upon the velocity of the journal. Okay. Increase in the relative velocity tends towards a decrease in the eccentricity of journal bearing centers. This is accompanied by the greater minimum film thickness. Okay. In hydrodynamic condition, fluid velocity depends upon the velocity of the journal. Okay. Next, in hydrodynamic condition, load is considered. Increase in load increases minimum film thickness. Okay. Okay. When load is increases, film thicknesses decreases and also increases the pressure within the film mass to provide the countering force. Pressure acts in all directions, hence it tends to squeeze the oil out of the ends of the bearing. Increase in pressure increases fluid viscosity. Increases in pressure increases fluid viscosity. Now we will try to see the functions of the lubricating oil, because lubricant plays a major role in the lubricating regions. The main functions of the lubricating oil are to reduce the friction between the parts and to reduce the wear between the parts, and sometimes it will act as a cooling medium to remove the heat. Sometimes it reduces the noise between the striking surfaces. Sometimes it acts as a sealing agent or sealing action take place. In some cases, it provides the cushioning effect, and in some cases, it provides the cleaning action also. Now you see the purpose of lubricating system. Just now we have seen the requirements of lubricating system. Now we will see what is the purpose of lubricating. In some cases, it acts as a lubricant. It reduces the friction between the creating thin film between the moving parts. Okay. In seals, in some cases it acts as a sealing agent. In some cases it acts as a cleaning agent. Okay, you can see in some cases it will act as a cooling agent. Nothing but it picks up the heat when moving through the engine and then drops into the cooler oil and pan, giving some of this heat. Okay. In some cases, it acts as a shock absorber. When the heavy loads are imposed on the bearing, then the oil helps to cushion the load. In some cases, it absorbs the contaminants. Here, the additives in the oil helps in the observing the contaminants that enter the lubrication systems. Okay, now you can see these are some references. Whatever the topic today we have discussed is taken from this references. That is nothing but the handbook of lubrication and the tribology volume 1. Okay, and also we also consider the lubrication fundamentals revised and expanded by Don M. Perio and Martin Webster and Yard Desner. Okay, we also seen from the website schoolcraftpublishing.com, and also we have seen automotive lubricants and the reference book uh, authored by John Willie and Sons of the 2020 edition Technology and Engineering. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.